Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am Dean Phillips and I am your host. I'd like to thank our sponsor, the Precision Metal Forming Association and the PMA's Educational Foundation for helping us put this show together. I have with me today Bob Southwell, where he comes to us from Aida, America, where he is the Executive Vice President. Welcome, Bob.
Thank you. Thanks for having me today.
It's great to have you here. So right off the bat, what is your key takeaway, or what do you see changing in the next 5 years?
Well, I guess, in the metal forming area that, we deal with here in North America and even globally is, of course, majority of the business is automotive driven, 80+%. And, the main things as we see continuing changing right now are the changes in materials. And this is true whether it's, EV or conventional, drivetrain. So we're seeing a lot of change in materials to the more exotic aluminums and, obviously the higher strength steels as the continually lightweighting occurs from model to model and going from higher and higher strength steels. And now we're seeing a lot of they call these new Gen 3 steels. And that's drastically changing the requirements for metal stamping, processes moving forward. And also, interestingly, is with the increased strength of these materials, will probably change a lot of the existing production for some parts from hot form processes back to cold forms.
Gotcha. Have you seen that these newer materials are causing the need for retooling of the materials, or is it more? Is the things like the Servo Press, are they kind of addressing some of those needs and special forming operations?
Well, I think, it does cause, some retooling or I guess, relayouts of the tools. Mm-hmm. Because, typically these materials versus older, materials which were much more malleable, with these higher strength materials, especially the Gen 3, is they work harden quite dramatically. So you basically have one opportunity to form, and then basically that's it. It's now work hardened. It doesn't matter how hard you restrike it and so forth. It's not going to take any change in shape. Right. So in the past, people used a lot of like restrike stations. So it was original form, and they allowed sometimes 2 or 3 restrike stations. Now the plus side is you can get rid of the restrike stations because they're basically useless. But then in that first forming station, you've got to be able to get it right. And that's where the servo technology has really taken off over the last 10 years. It's because with the formability capability of programming the stroke and doing what we call like rapid restriking. So again, you're restriking in milliseconds versus moving to another station. You're restriking directly in that station. Is you're able to get a much better, concise final form of the part in that shape.
Sure. Now, when you talk about retooling, do you see people going more? I know it's difficult now to find good tool and die people. Do you see people kind of venturing out into using the newer designs through like additive manufacturing and things like that? Do you see more of that coming into the marketplace?
I guess we, are more on the edge of the additive manufacturing, I guess, is, a lot of the, at this point, I think that's being used for a lot of very low volume vehicles or parts. But for especially, automotive or appliance and lawn and garden, because of the sheer volumes, it's not realistic to do additive manufacturing to make, millions and millions of parts.
Right.
So we're not seeing that so much in our area. So, it's really where people are progressing for is, you got to change their tooling, but you're absolutely correct. I mean, obviously there's a real challenge, in the tool and die area as well as manufacturing overall, including the capital equipment manufacturers. As the workforce is aging, there's not a lot of, competent, people, say in their 20s or 30s to step up to replace people who are now, say, retiring in their 60s. So it's going to be a real challenge over the next 10 years as far as tool and die. And as far as, where all the sourcing is going to come from. I guess a lot of people are trying to do more apprenticeship programs and so forth. Work with local community colleges and other things like we're doing here actually in Dayton. But it's there's some success, but unfortunately, a lot of young people still to this point don't understand that the interesting challenges that could be, and frankly, the very competitive compensation possibilities with relatively 18 months or 2 years of training.
Right. Yeah, I think that's still something that we battle with through the Precision Metal Forming Association and through the metal forming industry as a whole. We really still struggle with trying to get our message out with the value of a career in metal forming, and that's been a real challenge. So speaking of careers, tell us a little bit about your background.
Okay. Well, I guess I'm a bit of a lifer in metal forming. So I actually went to college in RIT, Rochester Institute of Technology in Rochester, New York, as a mechanical engineer. And through the co-op program, which was a great way to go to school because you get both the real work experience combined with the schooling. As I realized that I didn't really want to be a day-to-day engineer, and then sales engineering seemed like a very interesting path. So when I graduated, I kind of looked in that area, and then I interviewed the company Niagara Machine and Tool Works, which I know you're very familiar with, as you worked there as well.
Yep.
And they offered me a job as a sales engineer way back in 1988, which doesn't seem that long ago, but it is. So I've been in the business for 31 years, and so worked as a sales engineer, with Niagara, and over time did some product management, international sales, also regional sales. And I was there 10 years, and then in 1998, things were starting to get a little shaky there, as you were aware, with the ownership at the time. And so then I left and joined Aida in 1998, which was a great career move. And then I worked for about 7 years as the regional sales manager for the East Coast, and also as the appliance market manager. And then in 2005, was offered to move to Dayton and became the national sales director. And over the years, I guess, I picked up more duties as far as project management, product management, marketing department. Now as executive vice president, I have I guess you say more oversight over other departments as well. But I guess you say still the majority of my focus is in regards to overseeing sales and marketing efforts here in North America.
Excellent. But yeah, I think at this point, you and I are both lifers. I don't think that there's a huge career change coming in either of our future.
No, it kind of gets in your blood. That it's once you're into it, like it kind of. I always found it to be a very enjoyable profession because with metal forming, you're constantly always learning. There's not like you say with other machine tools, just chip speeds and table size, but just forming a part, there's many different methodologies to forming a part, and a lot of times go from customer to customer, and you see entirely different processes, basically making the same part. Mm-hmm. And it's always very interesting to see that and learn as you go, because it's like you say, in the last 10 years, with the changes with the materials, changes in technology in the industry, it's really become, I think, a most exciting time in again, my 31 career, because the technologies are changing, the materials are changing so rapidly. It's a very innovative time in metal forming.
Yeah, I think you're absolutely right. You hit it on the head. This is an incredible time for technology, especially in metal forming, which it has historically been a very slow reacting field compared to like fabrication, lasers, and of course fabrication equipment. They've been quick adopters to technology, but because of the nature, I think, of metal forming, we've always been kind of slow to react and get on board with things, because change isn't never been the friend of metal forming.
But now I think we're seeing a lot of customers are starting to react very quickly to it, or not all of them, but the ones that are being extremely successful right now are recognizing the chance for opportunities. and because it's a unique time to grow.
Yeah.
Because as they grow some of these abilities, as far as some of the new forming processes, technologies, it gives them opportunities to take on a lot of other work that historically they didn't do.
Right.
So, and so that's where we see a lot of the customers, like say the servo technology, the ones that have been, started investing into that, say back in shortly after the downturn back in 2010 or 2009, 2010, 2011, is that those are the companies that have seen this absolute phenomenal growth over the last 7 or 8 years. And I guess the key thing with the new technologies is take a servo technology, and of course other companies now also make servo presses, but the key thing with a servo technology is, you have to have, you can run a standard mechanical press, but it's up to you to program it to get the true benefits out of it. And so it's the customers who get the right engineers or manufacturing personnel on board who have, creative, innovative minds who are always looking to explore, how to improve a process. Those are the companies that have had this tremendous success. Some people get it. They do simple link motion curves or something like that. And we keep trying to tell them, like, guys, you're just scraping the surface. If that's all you're going to do, you're going to be left behind.
Right. And do you see that as far as engineering as well as your standard tool and die makers, do you see that they are understanding some of the challenges, or do you find that you have to spend a lot of time with training them, getting them educated on the materials, getting them educated on what's possible, and getting excited about some of the new designs? Do you see that being part of your task?
Oh yeah, we actually have several we call several application engineers. So a lot of what we do here is not just selling equipment, but it's more of engineered services, and really working side by side with our customers is with their tooling, to really show them how to innovate the programs with the servo technology. The first case is always to be able to form the part, to solve the issues as far as the new materials, as far as the ability to restrike, as far as thinning, cracking, et cetera, how to solve their production issues, and then of course to then program it to increase production rates. In a lot of cases, depending if you're able to shorten stroke lengths and everything, usually most people have at least a 30% increase in productivity. Some people increase productivity 150, 200, we even see 300%, and of course that becomes a game changer.
Yeah.
But a lot of cases we're finding is that as the workforce changes, I think a lot of our customers are becoming more and more reliant on supplier partners such as Aida, or I'd probably even say a Link, to provide more than just providing the quote unquote equipment.
Yeah, and I can see that nowadays because we do have much more of a difficult time in getting our workforces trained, and because of that, it does fall on sometimes these partnerships to help with that, because it is such a task now, I think, for most manufacturers to get good people, get them in there, get them in those roles, that they don't have enough time to do these things, to basically have somebody go through that learning curve, go through the process of learning all the technology. They need partnerships like that to succeed.
Well, companies are, we say right size, whatever, but I mean, most people are size where, everybody's got, they have at least 40, more likely 60 plus hours a week job, just, doing the daily firefight of maintaining production, maintaining uptime and all that. So it gives them very little time to spend the time to, do continuous improvement on processes.
Yeah.
So, I think the immediate fallback is, get the job running. Okay, it's running, that's good enough, and let it run, and never have the time to come back and work on it. And so, yeah, there's, people are always, stretched so thin that it's very hard to take time to learn new technologies, to step back and improve processes, whether in the tooling, in the capital equipment, and so forth.
Right. And can you explain to some of the people that may not be as familiar with it, what What is the Servo Press technology benefit to a standard manufacturer, somebody who's doing metal forming and has been doing it on a very small scale, but as they start to enter into servos, can you explain to them a little bit more of the benefits?
Well, the servo is, now before like a mechanical press, it had a set stroke length and basically a set speed or speed range, and it was basically turning on a hammer. And it does an eccentric motion and a certain speed. It comes down through the bottom and it goes to the bottom, or you hit an overload or you get stuck on the old presses. Well, the servo technology, and it's really innovated. Aida was the kind of the original innovator, starting in the late '90s, and introduced it in 2001. Was Mr. Aida said, servo motors have been applied to so many other things, servo feeds, servo transfers, and all that have programmability. Was that the press was still a dumb hammer.
Yeah.
And so, how do you move that forward? So now with the servo motor driving it and having the ability to program the motion and also program stroke length and speeds and slowdowns, it really allows people a lot of innovation now to first of all, I said, be able to form other materials. We're seeing a lot of introduction to other parts that we never saw before, like in aerospace or medical. And of course, automotive is the main thing, but some of these exotic aluminums, steels, and so forth. So be able to form the parts they had before with the challenges of the newer materials. And then also is what allows people to do is, be able to change stroke length and everything is, it gives you a lot of flexibility to run different parts in there. So a lot of times before, a stamper might be very specifically, like I run blanks. I mainly do blanking work. I mainly do deep draw work. I mainly do this stuff. Now the servo press, you have basically a fully programmable piece of equipment. So you can say, well, I can fit it in that machine, and I just got to write a program to make that part. So it's entirely different than what my core business has been. But, I can go after that now because I have this new technology. And so you see a lot of people start thinking about, broadening out. And also people are doing a lot, even say smaller manufacturers. You're seeing, the small presses, they go down to 80 tons on servo, is, they started incorporating some other assembly operations, hardware insertion, in-die tapping. So what they do is they get rid of all their downstream or a lot of their downstream, process work, put it into the press, and they have more of a complete, part / assembly coming off the end of the line. And, that's, become, I'll say a huge return at that point if you eliminate all the additional work and process and additional labor and so forth.
Yeah, the closer you can come to a completed part at the end of the line out of the press operation, the better off you are, because I think the value added on how much you can charge for a part goes up dramatically with the more you can charge. Because if you're just trying to make your money off of stamping out a part,
you're not. If you're going to do a cold, like you have say a 300 ton, and you're running prog die with simple cold roll steel. There's another 500 people that can make that part, and so you're basically scraping over pennies.
Right.
It's when you change and go after more difficult parts or start innovating and adding other operations, and that's when you separate yourselves, and now you can run with a much more livable gross margin on your product. And so that's where you're seeing those people starting to really accelerate. And again, this increased productivity rates really helps people out. Like we see a lot of customers now, and they've had very good presses, whether Aidas or Mensters and others. And as they incorporate the servo, because of the increased productivity and the increased uptime, in a lot of cases, they're doing now is taking out like 2 mechanical presses and replacing with 1 servo line. Mm-hmm. And so obviously, it's got a huge return, obviously in productivity, but also in recovered floor space and reduction in manpower requirements. And which is a whole other thing I think for everybody right now. Is the economy's pretty good, and pretty much everybody's got help wanted signs out, and are basically stuck that they can't grow anymore because they can't find any more people.
Right. Yeah, that's a sad situation, but in many ways it's good, but from a standpoint of trying to find people, it is a challenge out there today.
Yeah. So I mean, that's like everybody always talking most stampers. They again they could hire 20, 30 people. They hire them tomorrow, and of course then there's the washout they have. But but again, also you see going forward is as you start going to these more complicated, more sophisticated systems, the requirement is going to be a lot more. I think on the floor for people with a higher technical background, a little higher education, not saying college educated, but people with a little more aptitude as far as programming and so forth versus an old press operator. So I think you're going to start seeing people spending a lot more for operators on this type of equipment because they know they need higher quality, more educated people to be able to run these systems to be able to get the true return.
Sure. Tell me about now matching the speed. When we talk about matching the speed to the operation, one of the interesting things with servos is not just that you are able to run the part faster because you can adjust the stroke and things like that, but it's more about the fact that you can control the speed and match the operation. So if you're doing a tapping operation, if you're doing other operations that are staking or things like that, how does matching the time speed match up to gaining production?
Well, what you do is, like you say, just to say a simple one, like say in-die tapping is, what you do is you program, there's the working portion of the stroke and the non-working portion of the stroke. So the non-working portion of the stroke, you want to move as fast as possible through that, just to give you the right number of quote unquote say milliseconds to be able to do your pitch or transfer of the material, whether it's prog die or transfer. So you're really we think much more about milliseconds. So how long does it take me, my feeder, to be able to move that progression into the next die, or for the transfer to pick up the part and move it to the next station? So now you come into so you're always trying to cut that time out as much as possible, and that's the ability with the servo. You can do that. Now you get into the working portion of stroke. So you think in-die tapping, you've been able to do this for years in mechanical press, but the speed is fixed, and either it works or it doesn't almost, because it kind of gives you some slowdown on the way down, but it's too fast on the way up, and people would tend to break their taps. So now with the servo press, what we do is you come down and you program it now just slightly before your tap engages. And typically we do is we do a silent deceleration. You program a momentary slowdown, sometimes quite a bit. So you come down, instead of slamming the tap into the material, you suddenly slow down and let the tap engage. And then once your tap is engaged in a few threads, then you're actually able to start to speed back up, and then you move to actually constant velocity all the way through the bottle.
Right.
And then also on the way back up, you work at maybe slightly faster velocity, but you go up, and then as you leave the material, now kick the speed back up. And the nice thing is you're able to really play around with those things. So of course, you always want to maximize productivity, but maybe start out a little slow, but then start slowly increasing your tapping speeds, that contact speed, until you find that happy medium between, part quality, tap life, and part and what your actual production rates are. So the thing with people servo is, you tell people you start, and then you slowly walk in one direction, increasing speeds, and then you'll find kind of the happy medium point. As we said, you got to take the time to really, find that right efficiency in your operation.
Right. And I think that's where people get lost, is they kind of think of it, well, I should be able to run this. The faster the machine can go, the more parts I can make. But that's usually not the situation. It's limited by something else. It's limited by the tooling, limited by the part.
Well, there's always a limiting factor, and that's what we talk about servo programming, is find your first limiting factor. Maybe right. It's cracking in the material, or part control, and you design a program change to address that. And then you work to increase your productivity till you find the next limiting factor. And so, sometimes it's just on transfer. We talk about as people, the nature of the part is they move from place to place, that they have a hard time settling the part out in the next station, and they get a lot of nuisance faults. So it's how do you program to maintain part stability? So you keep working from limitation to limitation to a point where you basically run out of, you start with the low-hanging fruit, but you basically pick most of the fruit. Now you basically, you've maximized the productivity. But usually it's a series of steps that you take as you address each limiting factor, to the point of, we talked before about improving your product quality, eliminating all your issues with the part, and then how do you from there incrementally increase your productivity rate. You start first with the limiting factors and then work on the productivity.
Right. And I think that's where people kind of don't take advantage of their job. And even when they're predicting their OEE rates, a lot of times they're like, well, that press should run at 50 strokes a minute. So why are we not running at 50 strokes a minute? Well, the part can't perform at that rate. And that's where the advantage of the servo presses sometimes takes over, is when you can get into going from 20 to 25. That's huge.
Well, one of the key things with productivity rates, we talk about, and really some of our big customers really started talking about years ago, is they don't think so much of his productivity in the strokes per minute that the machine is running. They look at, parts per shift.
Yep.
And how many parts is my system producing over an entire shift? Because that takes in account all your variables. So the thing is, you can be running at 100, strokes per minute, but you get 30% downtime because of nuisance faults. While you're a hell of a lot better off running, 90 strokes per minute with, 3% nuisance faults. So it's a matter of what is your actual productivity over an entire shift. Not getting caught up in the quote unquote speed on the that's obviously part of it. Caught up in the speed that you're seeing on the display. But how many quality parts per shift am I making? And especially higher strength steels right now, the servo comes to this, you get changes in the coil itself, and so people will start making good parts and some of them are making bad parts, and this adds now to downtime. Mm-hmm. So that's been an enormous problem for people over the last 7 or 8 years. Obviously, the servo, you're able to program those variables out, so you're not having problems within the coil or going from coil to coil with the variables as far as yield strength and hardness that you can have with a lot of these new materials.
Sure. Well, I hate to tell you this, Bob, but we are almost out of time here.
No, I can talk all day. That's part of my problem being a career salesman, I guess. I don't know how to be quiet. So.
Well, you probably gained that over the years at Niagara.
Yeah.
Well, thank you, Bob. Hey, have a great Thanksgiving. I appreciate you taking the time here. I want to thank again our Bob Southwell from Aida, and I want to also thank Precision Metal Forming Association and the PMA's Educational Foundation for helping us put this show together. Thanks, everybody. Make it a great day.